Hi, my name is Blueberry. I'm an ice cream cone here at Slab. We're having a grand opening of a new store, but I don't know what ice cream I should wear. How many different possibilities could there be? I mean, I could be 1, 2, or 3 scoops, depending on how grand I want to be, and I haven't even taken into consideration the 42 flavors of ice cream and the 36 mix-ins to choose from. From all of these possibilities, I want to know how many combinations I can make from these mix-ins, sizes, and flavors. It would be great to know all my options to choose from. Now, to figure out this problem, we need to get into some math. Since we're trying to figure out the possible ice cream combinations, we'll need to explore probability. We've decided to use combinations to help find the answer to my problem. This is the combination formula that we use. This C represents that we are using a combination. The N represents the total amount of things that we have to choose from, and the R represents how many of them we choose. By doing this, we are able to see how many possible ways we can combine each ingredient. Since the order of the ice cream doesn't matter, combinations was our best fit. If the ice cream cone is a single scoop with no mix-ins, there are 42 options, because there are only 42 flavors. Then we found the number of scoops. Combinations 42 and 2 for 2 scoops, and combinations 42 and 3 for 3 scoops. These numbers represent the number of scoops there will be. Then we did the mix-ins. The maximum amount of mix-ins that can be in one ice cream cone is 8. So we did the combinations up until there are 8 mix-ins. But we did not do the mix-ins alone. To figure out the possible combinations of mix-ins and ice cream together, we multiplied the combinations of scoops with the combinations of mix-ins. If you want an ice cream cone with 2 scoops, there are 861 different combinations of flavors. If you wanted 5 mix-ins on that ice cream, then there are 376,992 possible combinations of mix-ins. Then you multiply each of the following to get 2 scoops and 5 mix-ins, and there you get it. 324,590,112 possible combinations of those variables. To get the grand total, we added up each of the columns to get the total of 507,697,006,628. That's a lot of choices. This is the math we did. But wait, what will Teresa Peanut Butter Cup wear? We mustn't take into account that she's allergic to peanuts. This breaks down the categories into 38 ice creams and 24 possible mix-ins of her combinations. Again, working like the problem before, we need to use probability to find the number of combinations. We can use the combinations formula to do this.
To find out what I will be able to wear to the grand opening, I must figure out what ice creams and mix-ins contain peanuts, as I am allergic. I found that there are 38 possible ice cream flavors and 24 mix-ins that I am able to wear. The next step involves us using the combination formula to find out all the possible choices. From this, we need to find the possible combinations for 1, 2, and 3 scoops. We also need to figure out the combinations of mix-ins for up to 8 possible mix-ins. Then, the same step as before is repeated. We multiply the mix-ins by the scoops. Now, just by looking at this chart, I can choose how many scoops of ice cream I want and how many mix-ins and see the total number of combinations I can choose from. By adding all of the totals, we are able to figure out that there is a total of 11,669,702,635 possible combinations that are peanut-free.
We have come to the conclusion that there are over 500 billion different combinations of mix-ins in ice cream in varying amounts of scoops and mix-ins, and over 11 billion peanut-free options. By using the combination formula of probability, we are able to find all possible combinations of ice cream flavors and mix-ins at Slab. This has helped me figure out all my options. Now all I have to do is choose one.